All right, for your handout, guys, just want to highlight, again, just making a video for the answers for some of these questions on this worksheet. So just a note, this hypotenuse here is 21.21 centimeters to make that a right triangle. And in number 1, we went through this one already. To find the surface area, should be 595.09 centimeters squared. And we'll do the second question here as well with you, just so you can check. Hi, this is still frozen, sorry. So the second question, let's take a look at that. Again, I would do these things exact same way. I would start with, the top surface, which is the circle here on this cylinder. And yes, we're going to be subtracting a portion of this from the top surface, but I would do the same thing for every question, just so you don't miss anything. So let's start with that top cylinder. So the area of the top part of the cylinder top, let's say, is going to be this is pi times r squared is the area of the circle, and r is 2. So pi times 2 squared, which is 4 pi. And on your calculator, you can use your pi button there. 12.57. 12.57. Okay, so centimeters squared. Okay, you've got that one taken care of. Let's take a look at the wraparound part here of the cylinder. And so that area there of the wraparound part is the circumference of the circle times the height. So that is 2 pi r times h. 2 pi r h. Very important for you to remember that. So 2 times pi times the radius is 2. The h is 1.5. Can someone grab that door, please? I'm not sure why all the commotion's out there. All right, so let's give that one a go. So 2, you can use your pi button again and round to 2 decimal places, times pi times 2 times 1.5 is 18.85, I get. 18.85. All right. Moving on. Now this is a rectangular prism on the bottom, so we have 6 sides, and all the 6 sides appear to be rectangles, right? There's no squares, there's no dimensions that are the same, so these are all rectangles, so it should be pretty straightforward. The top rectangle is going to be the same as the bottom. It's going to be 10 by 5. The top and the bottom are going to be the same. So that area of the top rectangle is going to be 10 times 5, which is 50. And there's another area on the bottom. Okay, so the top rectangle, the bottom rectangle is going to be 50 as well. You guys agree with that? Yeah. All right. So let's do the area of the front side here. That's this one right here. That's going to be 10 by, the height is 2. So 10 times 2, which is 20. Now the area of the back side over here is going to be the same, 10 by 20. So that's 10 by 2, so that's going to be 20 as well. So I'm going through this a little bit quicker now because we've done this, we've done each one of these 5 or 6 times already. So the only thing we have to do is area of side 1 and area of side 2, right? So the side is going to be this dimension, 5 by the height 2. So that's 5 times 2, which is 10 centimeters squared. And the other side should be the exact same, 10. Now, we do have to subtract the overlapping part of this circle, right? So there's a circular part here that is overlapping that we have to make sure we subtract that off. So I'm going to minus 12.57 at the end. So in effect, that's going to cancel off with this one, right? Okay, anything we've missed here so far? Does that look good? Looks good? Okay. So let's do area. Answer would be area total here is going to be, we don't have to touch the 12.57s. We already know they cancel out. So it's going to be 18.85 plus, let's do 50 plus 50 is 100, 20 plus 20 is 40, and 10 plus 10 is 20. We could probably do this in our head. That's 178.85 is what I get. 160 and 78.85. That's going to be centimeters squared. Everyone agree with that? Yeah. All right, awesome. That's what you should get for question number 2.
Yes,
Yep.
on the third page, how are you supposed to find
Okay. So on the third page, okay, you're talking about this one right here?
Yeah, the side lengths of the triangle.
They have those.
Yeah, it's good with this
They have everything.
Yeah, so, okay, so let's take a look at this one then. This is the third page question. So this is a little different in that the cylinder is on the bottom, but it's really the exact same as if it was flipped over upside down. So it's really the same as the first question. But the question is, how do you find this backside length? Is that the question? And the front length here? Okay. All right, so let's take a close look at this. I'm going to zoom in here just a little bit. Okay. Whoa, that's actually a lot, but okay. So we have a triangle on top, and I'll outline that triangle right here. And you're right, we don't know what this side is, and we don't know what this side is. But what we do know is, according to the markings here, this is a single stroke on this little half of the base, and this is another single stroke. So that means that this is cut exactly in half. So that helps, because we know that now that we have a little right triangle here, because there's a right angle there. So there's a little right triangle that looks like this. I'll bring it out and redraw it. So the height is 10. That's this one. And then the base is 5. And this is a 90-degree angle. So we can actually find the hypotenuse using Pythagoras there. Okay? And then this, whatever you find here for that side, is going to be the same as the bottom side, because it's a triangular prism, it says, sitting on top of a cylinder. Okay? So that one you will have to use Pythagoras to find that hypotenuse side. There you go. You put that phone in your bag or at the back, please. It should not be on your desk, okay? Thank you. Yeah, maybe. Let me just take a look here. Why don't you start this one? Can you start this one, okay? Because I've done both this way. Let me see what. If you can wait, show me at least the first start of that. Hello.
Would you go 5 squared plus 10 squared equals 2 squared?
Yeah, because this is the hypotenuse. So 5 squared plus 10 squared equals this side squared. That's correct. Yeah. You always add up the legs of the right triangle, so that's these two right there. All right, so let's take a look at the very last question on your worksheet. This one's a bit tricky, I would say. So let's think about this. Let me first of all explain the diagram. So the diagram is a cube. It says a cube here that has a hole drilled through it. So if we're trying to find, so we've got a cube with a hole drilled through it. Now, if you think about it, if you take that cube and you look through it, we're not going to have this circle. That circle is going to be removed. And so is this circle from the other side. That's not going to be there anymore, right? So we're definitely going to have to subtract the area of this circle twice. So minus 2 times the area of the circle. But what we're going to have to do is add now the inside surface area. The inside surface area of this hole. So think about it. It's a cube where you can actually stick your finger through there now and you can feel the inside of that hole, right? So the wraparound part is actually going to be area that you have to add. So you're going to have to find 2 pi r h for this cylinder, that's this kind of like a cylinder that's a hole here, and add the 2 pi r h. So subtract the circles and add the 2 pi r h. Okay? So I'm giving you some help with some of these questions. I did the first couple with you, I did a couple of them, so there's going to be 2 or 3 that you're going to have to do on your own here, okay? So you got a few more minutes of class. Keep working through those. These are the questions here that I'm giving you on your worksheet. Yes, question? You have a question? You stretching? Just stretching, okay.